Okay, so today we're going to talk about section 6.3, which is called similar triangles, and this is the section that you're going to have a quiz after. So we'll do a day of review after this, then the quiz. Okay, so there's going to be 3 ways that you can prove that triangles are similar. First way is going to be by angle, angle. Okay, and notice again the similarity symbol next to it. So it's angle, angle, similarity. So if you don't have that similarity symbol next to it, not going to work. Okay, so if 2 corresponding angles are congruent, then the triangles are congruent. So in this case below, triangle ABC is similar to triangle DEF by angle, angle, similarity. Again, right now I don't have 2 congruent angles, but I can find the missing angle in each triangle. So 74 plus 75 will give me an answer of 149. And if there's 180 degrees total in the triangle, when I subtract, I'm going to get an answer of 31. So now right away we have our 2 angles that are congruent. So triangle ABC congruent to triangle DEF by angle, angle, similarity. Wouldn't have mattered, by the way, if you found E. E would end up being 74, and then you could have said the 75, 75, and 74 was congruent to the 74. Okay, for the second way, we're going to prove triangles similar is going to be by side, side, side similarity. Again, super important to add that word similarity in there because these triangles are not going to be congruent by side, side, side. They're going to be similar by side, side, side. Okay, and the sides aren't going to be congruent. What happens is if all the corresponding sides are in proportion, then the triangles are similar. So these 2 triangles, and I'll show you why in just one second, triangle PQR is going to be similar to triangle STU by side, side, side similarity. Okay, so what we're going to do is we're just going to set up our proportions here. So I'm going to do 3/6 first, and I want to know if that's going to be equal to, let's do 4/8. Doesn't matter which ones that you do first. Okay, when I cross multiply here, 8 times 3 is 24, and 6 times 4 is also 24. So those pair of sides are in proportion. Now we have to do something with our last remaining side. It doesn't matter which part of this original proportion you use, so which other side that you want to do. You could do the 3/6 or you could do the 4/8. It does not matter. So let's do the 4/8. Again, I went little to big, so that means on the other side I have to go little triangle to big triangle, and I want to know this time, does that equal 5/10? And again, when I cross multiply here, 4 times 10 is 40, and 8 times 5 is also 40. So again, these 2 triangles are going to be similar by side, side, side similarity. And the last way that you're going to be able to prove triangles similar is by side, angle, side similarity. Okay, and what this one says is that if 2 corresponding sides are in proportion and the included angles are congruent, then the triangles are similar. So when we were talking about side, angle, side for proving triangles congruent, we had this included angle. And remember when we talked about the included angle, I kept tracing the sides that were congruent and saying that the 2 sides form that angle, that's the included angle. Here it's going to be the same thing, except we're not going to have the congruent side. We're going to be tracing the sides that are in proportion. So these 2 triangles, triangle JKL and triangle MNP, are going to be similar by side, angle, side similarity. Okay, so let's set up our proportion for the sides first. So I'm going to go 8, side that corresponds to is 6. So 8/6 is going to equal 20/15. Okay, and when I cross multiply here, 6 times 20 will give me 120, and 15 times 8 is also 120. So I have corresponding sides that are in proportion. And now again, if I trace those sides, notice it forms that angle. Okay, again, that's what it means to be the included angle. So again, those 2 triangles are going to be similar by side, angle, side similarity. Okay, so the first thing that we're going to do is talk about whether these triangles are going to be similar or not by one of the 3 ways that we just talked about. So either angle, angle similarity, side, angle, side similarity, or side, side, side similarity. Okay, if they're not similar, there is also that possibility. It doesn't have to be one of these 3. Okay, so in part A, I have two angles. So again, I'm going to have to find the third angle here. So let's find angle C first. So when I add 81 and 60, I'm going to get an answer of 141 there. And when I do 180 minus 141, I'm going to get an answer of 39. So that angle is going to be 39. Okay, so it doesn't look like these two triangles are going to be similar at all. I do have one congruent angle here, but 40 isn't equal to either the 60 or the 39. If you end up finding this angle over here, it's going to end up being 59, just so you know. Again, not going to be similar. So not similar. Okay, for part B, I don't know anything about the angles, so it can't be angle-angle similarity or side-angle-side similarity, side-angle-side similarity. So I'm pretty sure it's going to have to be, if they are similar, it's going to have to be side-side-side similarity. So I'm going to need to set up two different proportions here. Again, just be careful with your corresponding sides. So the first one that I'm going to set up is 20, and that side is going to correspond to 28. So 20 over 28. Again, I went the right-hand triangle on the top to the left-hand triangle on the bottom. So when I set up my next ratio on that right-hand side there, I'm going to have to do the right-hand triangle on the top again. So I'm going to do 16 on the top, and the side that that corresponds to in the other triangle is going to be 22. Okay, so we'll cross multiply here, and when I cross multiply, 20 times 22 is going to give me an answer of 440. And when I do 16 times 28, I'm going to get an answer of 448. So right away, these two triangles aren't similar. Once you get one proportion that doesn't work, then obviously the second might work, but it doesn't matter. Once you get one that doesn't work, they're not going to be similar. So not similar again. Next one, okay, for part C, I have some sides here, and I only have two pairs of sides, so it looks like if I'm going to do this one, it's going to have to be side, angle, side maybe, similarity, so let's see. So I'm going to set up my proportion, and my proportion is going to go 32 over 20, and I want to know if that's going to equal 24 over 15. So when I do 24 times 20, I'm going to get an answer of 480. And then on the other side, let's do 32 times 15, and that gives me 480. So far, so good. And now I need an angle. Well, the only thing that I can assume, again, is vertical angles. So that would be that angle and that angle. So those two would be my congruent angles. So now I need to know if that's the included angle. So again, I'm going to trace the two sides that we know something about. And that didn't form the angle that I need. So again, these are not going to be similar. Okay, let's see if D will come out to be similar. So again, I'm given two pairs of sides and I have an angle here. So again, this is going to be, if they're similar, it's going to have to be side, angle, side similarity. So again, let's set up our proportion. So I'm going to do 9 over 3 for my left side. And so the right-hand side of that proportion is going to end up being 15 over 5. When I cross multiply here, 9 times 5 is 45, and 3 times 15 is also 45. So again, the proportion works. So now let's see if we have our included angle. So again, I'm going to trace the two sides that I know something about. And look at that. This time it does form that angle. So yes, these are similar by side, angle, side, similarity. Okay, and it wants me to write a similarity statement. So that means I have to say which triangle is similar to which triangle. And remember, the order of your letters matters here. Okay, so I'm going to say triangle GFE is going to be similar to triangle RTS. I had to think about that for 1 second. It's G that corresponds to R when you twist that triangle around. Okay, for part E, hey, now I really know nothing about this picture. besides the fact that I have a pair of parallel lines here. Hey, so I have no sides. So I'm not going to be able to do anything that involves the sides. So I'm not going to be able to do this by side, angle, side, or side, side, side similarity. So my only option here is going to be if I can somehow prove these by angle, angle similarity. And again, I'm looking at this purple triangle and then this red triangle. Okay, well, that purple triangle and that red triangle share an angle already by reflexive property. So I have angle H. Now the fact that I have these lines that are parallel, I'm going to have parallel lines cut by a transversal, and I should be able to get another pair of angles out of that. So there's my parallel lines, there's my transversal, and I'm going to be able to say that that angle is congruent to that angle because they're corresponding angles. So now I have my two angles there. So yes, they're similar by angle, angle similarity. And again, I want to say what triangle is congruent to what triangle. This one's easier than the one above. Okay, so I'm going to start at the bottom left and go up and then back down. So triangle BHC is similar. So now I have to do the same thing. Bottom left, up, bottom right. It's going to be similar to triangle GHI. Okay, so now we're going to do a proof involving similarities. So I'm given that AB is parallel to CD, and I want to prove that triangle ABE is similar to triangle DCE. So again, I'm going to prove it by one of my three ways. So it's either angle, angle similarity, side, angle, side similarity, or side, side, side similarity. And when I look at my picture, I was told nothing about sides. Okay, and I'm given parallel lines. So if I'm given parallel lines, the only thing that I'm going to be able to show with parallel lines is that I'm going to have congruent angles. So I'm pretty sure the method that I'm going to be looking for here is going to be angle, angle similarity. So let's do our statements and our reasons. Okay, and we only have that one given. I have AB is parallel to CD. And again, I know that's true because it's given. Okay, so let's get rid of the obvious one first. Remember, the only thing that you can assume after your givens is if you have the reflexive property or vertical angles. And I have vertical angles here. So let's get that pair of angles right away. So angle AEB is going to be congruent to triangle CED. I've got my angle symbol. And that is because vertical angles are congruent. Okay, and now because I have my parallel lines, I'm going to be able to get another pair of angles. So what pair of angles are we going to get? Well, here's AB, here's CD, and how about we make that the transversal, which would make this angle congruent to that angle because alternate interior angles are congruent. So angle B is going to be congruent to angle C. And again, that is because alternate interior angles are congruent. Okay, and right there, I have enough information to say the true triangles are similar. So triangle ABE is similar to triangle DCE by angle, angle similarity. Okay, last one, another proof. So I'm given that AB is perpendicular to BD and EC is perpendicular to BD. And I want to prove two different things. I want to prove that ED over DC equals AD over BD. So that would be corresponding sides are in proportion. So what I'm going to have to do is show that the triangles are similar first. Then I'll be able to say that the corresponding sides are in proportion. And then once I can show part A, if I cross multiply, that's how they're getting this statement right here. ED times BD equals AD times DC. So here we go. Statements, reasons. Again, first goal is to show that the triangles are similar. Okay, and again, from my givens, I'm given something about perpendicular lines, which is going to be an angle. So I'm pretty sure, again, I'm going to have to prove these congruent by angle, prove them similar by angle, angle. And then we'll be able to do the, again, the corresponding sides are in proportion and then the cross product. All right, so my givens. AB is perpendicular to BD, and EC is perpendicular to BD. And the reason I know that's true is because it's given. Okay, so again, perpendicular lines are going to form right angles. So where are my right angles going to be? Well, if AB is perpendicular to BD, that's going to be my one angle, and EC is perpendicular to BD, that's going to be my other angle. Okay, so I can name this angle using one letter, but I can't name this one using one letter because I don't know if you'd be talking about the angle that I just put in the dot in or that angle on the right-hand side. So please make sure that you're using 3 letters to name that second angle. So angle B and angle ECD are right angles. And why is that true? Because of definition of perpendicular lines. Perpendicular lines intersect to form right angles. Now that I know that they're right angles, now I can say they're congruent. So angle B is congruent to angle ECD, and that's because right angles are congruent. Okay, the next thing that I'm going to say, again, by the way, I'm trying to show that this triangle is similar to this triangle. Okay, so next thing I can say is that I have the reflexive property for that angle. So angle D is going to be congruent to itself. Angle D is congruent to angle D, and that's going to be by the reflexive property. Okay, so now I have my 2 angles, so now I can say that the triangles are similar because of angle-angle similarity. So triangle ADB is going to be similar to triangle EDC. Again, remember, order matters there, okay, because of angle-angle similarity. And now that I know that they're similar, again, what we've been talking about so far in this entire chapter so far is that corresponding sides of similar triangles are in proportion. So now I can say that these sides are in proportion to each other. So ED over DC is going to equal AD over BD. And the reason that that's true is because corresponding sides of similar triangles are in proportion. Corresponding sides of similar triangles are in proportion. Okay, and again, now that I have them in proportion, you have 2 fractions that equal to each other, you can just cross multiply, and when I cross multiply, I'm going to get that. So now I finally have my second piece that I need to prove here. So ED times BD is going to equal AD times DC. And again, the reason that that's true is because of the cross product property. Helps if I spell property right. So the cross product property is that reason. Again, that's cross multiplying.